Good morning to all. Today I am going to take signal flow graph. By using signal flow graph to find the overall transfer function of the system. Okay. Here one problem is there to find the overall transfer function of the system by using signal flow graph is given by here 8 nodes are there. The nodes are represented as 1, 2, 3, 4, 5, 6, 7, 8. Then the magnitude is represented from node 1 to node 2 1, then node 2 node 3 G1 of the system, 3 to 4 G2 and 3 4 to 5 G3, then 5 to 6 G4, 6 to 7 G5 and 7 to 8 1, where R of S is the input of the system, C of S is the output of the system. From the problem, then one more feedback is represented from 3 to 4. That feedback is represented as a minus H1. Then feedback 2 is represented from 5 to 3, that is minus H2. Then feedback 3 is represented as a from 7 to 6 H3. Then one more forward path is represented in the problem 2 to 5, that is the magnitude is represented as a G6. From that, this given problem to find the overall transfer function of the given system. Here the solution having 5 steps. Let us see one by one. Step 1 to find forward path gain. Step 1 to find the forward path gain. Here first how many forward paths are there? Here the number of forward paths are k is equal to 1, that is from 1 to 8, that is 1 forward path, 2, 3, 4, 5, 6, 7, that is the forward path is represented in the figure 2. Six, 7, 8. This is the magnitude is 1, G1, G2, G3, G4, G5. Then the magnitude is 1. Here the forward path gain is represented as here P11, that is 1 into G1 into G2 into G3 into G4 into G5 into 1. There is G1, G2, G3, G4 and G5. That is forward path 1. Then second forward path is represented from 1, 2, again 5, 6, 7 and 8. That forward path diagram is represented 1, 2, then again 5, 6, 7, again 8. The forward path flow path is represented like this. There is 1, 2, 5, 6, 7, 8. The magnitudes are here 1, this is G6, here G4, then G5, 1. The forward path gain is represented P 1, 2, 1 is 1 into G6 into G4 into G5 into 1. That is G4, G5, G6. This is the forward path gain 2. This is the forward path gain 1. The number of forward path is represented as here 2. That is step 1 to find the forward path. The two forward path, the forward path gains are P11 and P2. That is first step, that is forward path gain. Then second step to find the individual loop gain. Here next step to individual loop gain. Here from the given problem to find the individual loop gain of the system, that is closed loop. Here one loop is 3, 4, again 3. This is one individual loop. That will be represented 3, 4, the magnitudes are represented as G2. Here the feedback is minus H1. Then second loop is here 3, 4, 5, again 3. That is 3, 4, 5. Then again the loop is represented as minus H2, 3, 4, 5, G2 and G3. This is the second loop. Then third loop is represented, this is the one closed loop. 6, 7. Here 6, 7, G5 minus H3. Here to find the loop gain for the individual loop, each loop, that will be represented as here P12, that is minus G2H1. Here P22, G2 G3 minus H2, minus G2 G3 into H2. This loop gain, that is P33, G5 minus H3, minus G5 and H3. This will be represented individual loop gain. Then next step to find the two non-touching loop. Step 3 to find two non-touching loops. Gain products of two non-touching loops. Here the individual loop. Here this one is the individual loop. 3, 4. This is the one individual loop. Second loop is 3, 4, 5. Again 2. Here the two nodes are touching. Okay, this is the touching loop. Then 3, 4. This is the one closed loop. But 6, 7 nodes are non-touching. Therefore, one of the non-touching loop is 3, 4 minus H1 G2 loop 3, 4. Here 6, 7, that is G5 minus H3. This is the one non-touching loop. Then again the loop is 3, 4, 5, again 3, 6, 7. This is also one of the non-touching loop. 3, 4, 5, 3, 4, 5 minus H2. Here G2, G3, 6, 7, G5 minus H3. These are the two non-touching loop. When consider, this is 6, 7 node, this is 3, 4. Both are non-touching. Here 3, 4, 5. Here 6, 7. Both are non-touching. The gain product of non-touching is first P21 is minus G2 H1 into minus G5 into H3. That is G2 G5 H1 H3. Then second two non-touching loop is there is P22 is minus G2 H2 into minus H3 into G5. There is G2 G5 H2 into H3. That's all about the two non-touching loops. Remaining loops are, these are the 3, 4, again 3, 4, 5 is touching. Okay. Then next step to find the calculation of del and del K. Del and del K. To find del, the formula for finding del 1 minus sum of individual loop gain plus sum of two non-touching loops. Sum of two non-touching loop gain. This is the formula for finding del value. That is 1 minus, we already calculated P11, plus P12 plus P13, then minus plus P21 plus P22, 2 plus P33. This is the non-touching loop gain. To find the calculation of del, then del K. Del K formula to find 1 minus the non-touching path of the kth forward path of 1. Then let us consider based on here 2 k forward path, there is del 1 and del 2. Del 1 is 1 because all the nodes are touching. The K2 there is 1 minus this path is not touching. There is 3, 4, 1. There is P11. That's all about the calculation of del and del K. Then last step to find the transfer function. That is 5th step. The transfer function of the system. Transfer function of the system. Here the signal flow graph we are using Mason's gain formula to find the transfer function of the system. The Mason's gain formula is the transfer function T of S is equal to 1 by del sum of del K into Tk, where 1 by del, here 2 forward paths are there. K value is 2 forward path, therefore represented here P1 del 1 plus P2 del 2. This is the final transfer function of the system formula. We know the values of P1 del 1, P2 del 2, then del value to find the overall transfer function of the given system. That's all about the signal flow graph problems. Thank you.